Hey, I think we're live. Are we live? I don't know. Alright, so what I'm going to go ahead and do today is I found a couple modeling challenges in r/SolidWorks, and I'm going to go ahead and try to model them, although I'll be doing them in Onshape since I'm a Linux user, so that's how it goes, I guess. Alright, so let's go ahead and start. I'll just unhide this to start. And first challenge, it's in millimeters, grams, and seconds. So just double check that my units are correct, millimeters and grams. Alright, so let's get cracking. So I'm going to go ahead and start this out with a sketch here. So we've got a rectangle right there. And it looks like our front view is going to be in this direction. So this is like a top view, this is a front view, so I'll do a rectangle here. And this will be, looks like 270 by 140. Neat. Now let's add the circles. So this one is 2 times the radius of 50. And this one's going to be 2 times the radius of 25, I think. Right. Oh, and one thing I almost forgot. Need to start the music. Let's do that. Okay, next dimensions. So dimension from the center point to the side. Let's go ahead and say 70. I think that's what it's supposed to be. For this one, I think it's 45. It's looking all good so far. Alright, and oh, I know I'm forgetting something. Okay, so split lines. So just add a couple lines right there. And we'll want to mirror them across the front plane. So select those. And each of these angles is 110 degrees, I believe. Okay, neat. Let's go ahead and extrude this. So select all that and we'll extrude it down. What's that, 20? Alright, and let's do another extrude and hide this again. And in this case, I think it's 70. Cool. One last one. This one's 10. Neat. And now we'll get on to splitting stuff. So split some faces, split the 2 cylinders, and we'll just go ahead and use these sketch lines that we had earlier. So this should give us 2 4-sided faces that we can loft between. Now let's use the loft, and we'll loft between these 2. Whoops, not draft, loft. Cool, that's looking pretty good to me. Now let's just go ahead and assign the material. I think the SolidWorks materials are a little different, so I'll use these that I have preset for these live streams. And let's go ahead and hide everything to clean it up, add a nice appearance, and sit back and hope that our mass is correct. Yep, looks like it's just right. Fantastic, so that's 101. Now if you want to go ahead and look at what's going on here, there should be in the description a link to this document that you should be able to open. Just paste it into a new browser window. Even if you're not signed in, you can still follow along. It might take a second to load. My computer is a little bit drained right now with the stream, the music, everything else that's going on. Alright, so that's one down. Let's go ahead and try the next one. Oh, this was already that one. Alright. And if you want to try these out, I also have the posts linked in the description. Alright, so this star says that you're only allowed to use solids. Using surfaces is not permitted. Alright, so this looks like it's kind of a loft from a triangle out to the point. So we'll probably want to start with that. Let's go ahead and... So looking at this top profile over here, where was it? So it's 70 out from this sort of pentagon thing. Alright, so let's start with a pentagon shape then. So go ahead and use our polygon tool here and match the orientation. And I think we only want 5 faces. Okay, so the distance from the tip to the point there is 20 millimeters. So we got that basis formed now. Now we just need to get the tip out here. So this distance over here is marked as 70. Right. So next, the tricky bit, we need to figure out how to get this triangle all in place. Okay, so I think that I know how I'm going to do this. Let's go ahead and start a new sketch. So on the front plane, and this will be what our triangle looks like. So For now, I won't really take too much care with this. Actually, I'll just make sure that there are no constraints applied. Now we're going to want to pierce this over here. Pierce relation like that. Pierce relation over here. Put these above there, and I think we should be set here. Or, what was this, a dimension of 10 millimeters, I think? Yeah, 10. Cool. I'm really hoping that this will work out. It'd stink if it doesn't, not sure where to go then. So let's try a loft. Loft from here to the point. And we'll want to do a circular pattern next, I guess. Circular pattern, the axis of the pattern. Let's go ahead and use that pentagon from the first sketch as our axis. We want 5 points from the start. Okay, is that made out of 1060 alloy? Oh, wait, but we need to make sure it's just one part. So it's again over here from the SolidWorks materials. Okay, and appearance is the most important part. Maybe let's try a little bit of an orangey one. Okay, well, hoping for 45.59 grams. Ah, shucks, we're over. Let's figure out what the problem is. Okay, so it seems that I misjudged the triangle here. Oh yeah, if we zoom in, then the triangle is not... Okay, so we need to reassess our strategy a little bit. So we'll want to go back into this first sketch. It looks like we need to make sure that these lines come out right here. So, notably, this point over here doesn't quite line up with this line. So let's go ahead and do that again. So we'll put this line right here, put a coincident right here. And now we'll want to mirror it to get the other side. Okay, and now we'll want to just show these constraints and disable these pierce relations because I don't think they're helping us. Rejiggle it like that. Alright, now that's looking better. 45.59 grams. 45.59 grams, fantastic. Alright. Let's move on to the next challenge. Huge thanks to you/CADNurd for putting these challenges together, by the way, lots of fun. Okay, parts symmetrical, be sure to mirror, probably doable in 5 features or less. Alright, let's go ahead and figure out how we're going to approach this. So it looks like we've got chamfer on the top here. You got this profile from the top down, and then there's this cutout from the side. So what's the best way to approach this? I think I'm probably going to start with a blank of the material kind of going from the front, and then we can cut out those inside profiles there. Alright. So let's start with a sketch from the top. So this looks like... Oh, what's the... Okay, 56 by 6. 56 millimeters by 6 millimeters. Great. Now we've got the circle right here. Looks like the diameter is 12. And I think we'll want to add some fillets in here. Okay. What is this? Radius 2. So Shift F for fillet. Add these for 2 millimeters. We might as well put the hole in there too. I mean, it's not exactly best practice to put all of the features in one sketch. But this will save us on feature count, and the challenge was 5 features, so let's go for it. Height's 54 millimeters. It's looking pretty promising so far. Now let's try to get these cutouts out. So we got these slots in this rectangle. I'll start with the rectangle since that looks easiest. It's 24 millimeters wide, but what's its height? Oh, 4. 4 millimeters is its height. And we'll want a dimension from here down to the top plane for 14 millimeter offset like that. So just get these arranged like they're in the original. Okay, next up is a slot. Slots are, looks like 23 millimeters. Let's make that construction just for, if we have any design intent going on here, it'll be over there. I never remember where the slot tool lives. Oh, right there, okay. And the radius is 3, so rather than giving this a diameter, I'm going to go ahead and delete that, and we can re-add the dimension as a radius. Oh, actually, let's put it on the bottom so it's even more consistent with the original. Radius of 3. And it looks like we're dimensioning from the center of the bottom right here. $8 millimeters, 23 millimeters. Okay, time for the mirror, and I think we're almost done with the sketch. Just one last feature after this mirror. And, well, this dimension across here like that. So you just got to get this triangle cut out right here. So it's a 90-degree angle. Goes down to a width of 8 right there. Alright. Let's go ahead and use a mirror and save us some work right there. You know what, better than 90 degrees, let's go ahead and just make it perpendicular. We can make the point coincident to the face like that. Dimension this out to be 40 millimeters. Set this to be 8 millimeters. And the distance from the bottom is 32. Okay. So I think this is all that we need. Oh, we just need a line right up here. Alright, extrude, symmetric, through all, and remove. Great, that's looking pretty good to me. Oh, shucks, but hold on a minute. We're going to need to handle this chamfer right here. Okay, so how to do this? Let's just go ahead and add the chamfer and then we can go from there. Two and 3 millimeters, I believe. This doesn't quite look right. So we'll probably want to add, shucks, that's going to hit the 5 feature limit. Ah man, how to do this? So what's going on with the geometry here? Looks like it's supposed to go straight down right there. Oh well, I guess we can't make the 5 feature limit. Okay, how to do this? So I think what it wants us to do, if we just cut this out from looking from the right, I think we'll be okay. Set this line to be coincident here, this line to be coincident with this face. Let's just string it all the way up to the top here, and for good measure just have it extend as far out as we can. Mirror across this plane, extrude, symmetric through all. Okay, and now the chamfer should behave better. I spoke too soon. Why is it having a disagreement right now? Okay, let's just go from nothing here. It still doesn't want to cooperate. So if we just try this edge right here. Ah, okay, so it's that face transition right there. Okay, at this point, I'm erring on the side of getting things done, not necessarily by best practices, but I'll just go ahead and I'll hack my way through it to get on to the other modeling challenges. So what I'll do, actually we can probably ignore this old sketch right here. So this sketch and this extrude, We can throw that out and do it a little bit more of a hacky way. Oh wait, hold on a minute. What did we do right there? What have we done? Okay, so down right to this face, we just need it to continue like a rectangle. You know what, I'm going to suppress it just in case we need to bring it back. Alright, so sketch on top of here. And we'll want to make, what's this going to be? A line from this face over to here. Back up vertical, back over to here. I want this to be coincident with that. This dimension's 2 millimeters and this other one's 3. Looks like we're almost fully defined. It's not fully defined. Whoops, that's not good. Okay. And now we'll just want to cut out this rest of the surface right here, so I think I'm just going to lock that off with a triangle. Nothing too fancy. And then mirror time. Mirror like that. Mirror like this. Oh, the music stopped. Hold on, let me restart it. Alright, now's our extrude through all time. Okay, and then the chamfer. It's not meeting up at the corner nicely though. I mean, at this one it is, but this one's not having it. Seems that these are disagreeing about which side they're doing it shorter on. So let's go ahead and try it one side at a time. Alright, so we definitely got the right one down like that. Let's repeat the process on the other side. Alright, not my best modeling, but I think we got it done. So, ABS plastic, let's do that. Add the all-important import, the all-important appearance. Check that mass. 13.36, 13.28. Wow, and something's not quite right. Do I want to call it good enough? I'll say good enough for now. Bit of a bummer that I couldn't figure this one out, but oh well. On to challenge 4. Okay, what's this one? So we've got a couple ellipses, some interesting tangency, and this triangle profile. Alright, looks like we can probably start with this base over here. So this will be a couple of ellipses. So major axis is, what's this? 150 by 50. And 50 by 50. Let's do this as one extrude. Height of 10. What is the fillet? I remember seeing it over here somewhere. Radius 5. Fillet the face. Okay. Now we've got another ellipse to take upwards. So that's up to a height of 50 from here. So let's go ahead and sketch from here. Remember this axis was 100 millimeters, but what was the other one? 24, great. Let's take this up to that 50mm height right there, and start cutting the material away. So looking from the right side, it looks like we need to take away these triangles over here. Comes to a point right there, so let's do that. We'll add a couple pierce relations here. Actually, just one pierce relation, and then this one's going to be coincident right there. Great. Mirror across the front plane? No, right plane. And let's actually not really close it out, rather put stuff on the outside. Should have done that mirror a little later. Okay, so if you're just joining, you can follow along in the document. Should be a link in the description. You can just open it up and see what I've got so far. I'm currently going through a few challenges that were posted on r/SolidWorks just for the heck of it, really modeling practice. So if you have any questions, feel free to drop them in the chat. So we'll want to do this extrude through all and symmetric. Looking pretty good. Now let's go ahead and add the other cutouts over here. So there's a 5 wide triangle. Actually, let's start with this rectangle here. This one's a little tricky. So what's the width here? 10mm? Height? It's not specified, I don't think. Oh, no, it's 10 put on the other drawing. And then the offset is 7mm down here from the face here. Doesn't want a dimension to that curve. Well, dimension to the face then. 17mm up, we have the base of the triangle. So I'll put that up here. Let's do a little mirroring. 5mm width, and we'll make it parallel to these sides over here. Okay, that's all looking good to me. Boom. Alright, great. So we've got most of the shape done now. We just need to work on, I think, the holes and this front cutout stuff. Oh, and there's this interesting tangency stuff. Okay. So let's go ahead and start sketching on the front plane to work this out. Easy part here is the ellipse. It's 22mm along the minor axis. Where does it go down to? Guess we can figure that out later. Oh well. Thanks, Mark. Okay, so next we've also got that hole from the top. I don't know how to proceed though, because we have this ellipse here. Alright, let's just work on these tangent arcs over here. Radius is 30. Want to get this tangent to the top right there and use an intersection curve. Oops. Where was that tool? Okay. So that's looking good to me. Now, let's get some lines around here so we can cut this out. And do the mirror too. And we still need to figure out that dimension for the ellipse, but well, it's a bit of a mystery. I'm having trouble finding it in the drawing. Okay, that cutout's looking good. Now let's work on this hole that we have from the top here. So it looks like there's some sort of counterbore that goes down to here. It's 12mm through, but then... what is this diameter right here? Is that the 24? No. Oh, that's the diameter of the circle. Okay, never mind. We didn't need the ellipse in the first place. Okay, that was a bit silly. So let's go and turn this into construction, or well, let's just delete it since we don't need that. So going from this face over here, we're going to have a 22mm diameter circle that just punches through. Better yet, we can just use a counter bore hole. Alright, so let's use a hole tool. We'll want to center it in the face, and want it to be counter bore. Actually no, never mind. I'm going to just do the extrude. Might be a little tricky to do it that way. Okay, so now all that we have left to do are these holes. So we've got 12mm hole in the middle, and 4mm holes along the edge. So what's the shape that they're following? Curve-driven pattern using outside perimeter. So I guess this inside distance is going to be 6.5 right there. Let's do this from the bottom since that seems to be the way it's specified. Maybe I can just do this with the mate connector, that would be really cool. No, but there isn't a hot point right there. Let's just do a point right here. Doesn't want it to dimension to there. Okay, so let's get on to this. I'm hoping that the curve pattern will cooperate. Feature pattern this hole around this ellipse. And we'll want to do apply per instance since it seems to be complaining about the fillet faces to some extent. Alright, all that's next is to apply the material, so it's the 1060 alloy. And let's add a nice appearance. Whoops, not to the face, the whole part. Okay, fingers crossed that we've got the right mass. I'm not super hopeful though. 234.37. Fantastic! Okay, so that's 3 out of 4 correct. Challenge 3 was a bit of a miss, but 1 through 4 I've gone alright. Okay, so let's get on to this last one. So it seems like some sort of horseshoe object. If I had to guess, it'll start with a revolve. So there's this revolved profile right there. I got the front view right there. I wonder what's going on right here. Like, is there a little rib right there? That's probably what it is. Alright, well we can model the rest. I'm not quite sure what this drawing is specifying right there, but we'll figure it out. Okay. Go ahead and do a center point arc to start this out. Distance right here is 120mm. Distance to the center is 87. These 2 points are horizontal to each other. And then the diameter is 122. So this is dimensioning the radius, so we'll do 122 divided by 2. Great. Alright. So we've got that arc right there. Now, okay, so I could do this as a revolved profile, but I think it might be a little cooler to instead do it as an extrude and then a full round fillet. So to do that, let's go ahead and use the slot command to get an offset from either side. It's 10 and then 5 and 5 on either side, so the default 20 looks pretty good to me. And we'll want to cap off the ends right here. And make this construction, and we should be able to extrude this out the symmetric depth of 10. Alright, now let's go for the full round fillet. So full round fillet, first side, second side, third side. And first side, second side, third side. Wait, We don't want this right there though. Or can we handle that? I think I'll actually have to leave it, and we'll have to handle these little bits out here. So these look like spheres that are on the end. Yeah, spherical. Okay, so let's, before the fillets, go back to here and let's add some spheres. So I have a feature script that'll help with this. The radius is 12. Join them all together. Okay, and now the full round fillet should cooperate. Ah, no, but they want to take out those edges there. Oh well, we can do it the less elegant way and just do some regular old fillets. Or not? Why is it complaining so much today? By moving it up here. Okay, well, we got the result we needed one way or the other. Next up, we need to get these holes in here, and we need to cut off this distance here. So where will that be specified? Okay. So let's do, since we got a width of 14 right here, we can pull off a special fancy trick right here. Drag this out to be further than there. I really want to get it constrained though. Oh well, we can leave like that. And we can do a through all symmetric intersection constraint, so this will just keep the inside. Now I've got these two 9mm holes. 9mm, and then we'll just go ahead and choose the center points of the faces. Looks good to me. Now we just gotta handle this little tube part right there. So that'll be a 32mm circle in this top plane, I think. For a distance of 44mm. Now we'll need to knock a hole through it. Looks like it's... Yeah, you know, I'm still having trouble figuring out what it's asking for here exactly. Because it seems like it wants a rib on the inside here. Oh no, it's a slot. Okay, it's a cutout. Okay, that makes so much more sense. So it'll be a diameter of 24mm. Okay, and then it should be smooth sailing from here. So I'll just make a rectangle right here, and add a nice center line for us to work with. I can do a symmetric dimension across here for this diameter, which is 28. Two millimeters and then 6mm. Alright, I think that's all the features. So just gotta add that 1060 alloy. Add a nice color. Okay. 167.06 grams. It's looking great to me. Awesome. So 4 out of 5. Pretty happy with that result. I kind of want to revisit challenge 3 to see if we can figure out what to do here. So I guess I'll start by stepping through the dimensions here. This is supposed to be 24mm. This is supposed to be 4mm tall. And the slot is supposed to be 16mm off the top plane. Alright, so those 3 are checked. We've got a radius of 3 here, hopefully. Distance of 8 from the center point down to here. Center distance of 8. This center to center distance should be 23. Okay. Distance over to here should be 32mm. So far everything's looking pretty good. This should be 42mm, I think. Center to center 42. And this should be 56. Alright, no issues so far. This area of the dimensions is looking pretty good. Okay. My gut feeling is that it has something to do with the sections being wrong up here. So first, let's check the center distance over here. 40 millimeters looks okay. The angle between the faces, 90 degrees, also looks okay. Distance between here, 8 millimeters. Thanks for watching, Mark. All right. So we've checked that stuff off. Now let's check this relative distance over here. So this is distance of 3 vertically and 2 horizontally, what it should be. Oh, there's no chamfers on the top edges. That's it. Okay. All right, I'm feeling pretty good about this now. That was probably the issue. Got the final mass over here, 13.36, 13.36. Fantastic. That's it. Awesome. So we got all 5 challenges done. So I guess I don't really have anything else planned, so I'm probably going to wrap it up then. If you want to check out what I made here, there's a link in the description to this Onshape document. You can just make a free account if you want to edit it, or you can view it without an account. And there's also links to the original Reddit post that I did, as well as in the description of this YouTube video. Thank you so much for tuning in, and I'll hopefully see you guys around next stream. I'm thinking of maybe doing a work stream for the underwater robotics or satellite projects that I'm working on. In any case, have a good night. See you.